This is problems number 6 and 7 on the review. We're going to look at the vertical line test. So we've already looked at relations and equations and whether or not they represent functions. Vertical line test is probably the easiest. So if you can find a place where you draw a vertical line and it crosses your graph more than once, then you know that it is not a function. So remember, a vertical line represents one x value, and this one x value has two corresponding y values, and that makes it not a function. If I look at the second one, no matter where I draw a vertical line, I am only crossing my graph one time. So that means that this one is a function. And for the last one, so if I draw it here, it only crosses in one place, but if I draw it over here, then it crosses in 3 places. So if you can find a place, just one place where it crosses more than once, then we say that this is not a function. All right, so moving on to number 7, we're going to talk about domain. So this is domain from equations. So when you're looking at domain on equation, there's 2 things that you have to remember. No zeros in the denominator. And the other thing we have to watch for are no negatives under square roots. So when we're talking about domain, we're basically making a list of x values that we're allowed to use for the problem. So a list of input values. So if I look at a, I don't have a square root, but I do have a denominator. So what I know is that x minus 7 is not allowed to equal 0. Now if I solve that, that means x is not allowed to equal 7. So for my domain, I can have anything except for 7. So we might list the domain. You could do interval notation if you want, but you don't have to. You might say all real numbers except 7. Okay, so that would be a good way to do the domain. If you did it in interval notation, let me write that up here. You would take your whole graph, except you would have a hole at 7, so you want everything but 7. So in interval notation, that would be negative infinity to 7, union that with 7 to infinity. So that's another acceptable way to write the domain for part A. Now if we look at part B, I don't have a fraction, so I don't have to worry about zeros and denominators, but I do have a square root. So I know that I'm not allowed to have a negative value under my square root. So I pull out that part under the square root, and I'm thinking if it's not allowed to be negative, it is allowed to be positive. So another way to think of positive is greater than 0, and it's also allowed to equal 0. Okay, so by writing it this way, I've taken all the negatives out because I'm not allowing it to be less than 0. So then if I solve that inequality, I get 2x greater than or equal to 4, and I get x greater than or equal to 2. So when I write my domain, I have a couple of options. I can leave it in inequality form. I want all numbers, real numbers greater than or equal to 2. Or if I think about that in interval notation, that means anything 2 or bigger. So 2 on up to infinity, but make sure you include the 2 itself. All right, then when I look at C, I have no denominators. I have no square roots. So remember, those give me the values that I need to take out. So for C, I don't need to take anything out. So my domain will be all real numbers. And you can write it this way. In interval notation, that would be everything from negative infinity to positive infinity with parentheses.